So now I want to walk through the Newton's second law problem solving practice. So this was the second practice for this week. And this one is a little more involved because these don't have the free body diagrams drawn for us. But I want to go ahead and write at the top the three equations that we need to make sure that we know when solving forces problems. We're going to have our force of weight is equal to mass times gravity. Our sum of forces or net force is equal to MA. And also that our force of friction is equal to mu times the normal force. So those are three equations that you might just want to jot down at the top of your practice just to make sure that we remember what equations we need to work with. So we're going to work out a couple of these because they do kind of have a different little spin on them. So number one says a rightward force of 320 newtons. I'm just going to go ahead and circle my givens. Is applied to a 28.6 kilogram crate to accelerate it across the floor. The coefficient of friction between the crate and the floor is 0.75. Determine the acceleration. All right, so the first thing I want you guys to do on these problems is draw your free body diagram. So the very first thing I want you guys to do is just draw a square and some arrows. So remember that square represents the object and the arrow's going to show us what forces are acting on the object. So if we have a crate resting on a floor, we know no matter what's going on, we always have force of weight or gravity going down. We're going to have our normal force going up. And then we're going to have an applied force to the right, which would be a little larger than our frictional force going to the left because we're accelerating. And remember, acceleration means we have unbalanced forces. So looking at this problem, now I just want to write out my list of givens. So the problem tells us we had a rightward force of 302 newtons. So we're going to just label that as our applied force. Then it tells us our mass, because we recognize kilograms as mass. And that coefficient of friction is going to be that weird Greek letter, or that mu, which lets us know how hard it is to move objects across the surface. And we're looking for acceleration. So you're probably thinking, what in the world am I going to do with all this information? So what we're going to do next is, after we have step one is free body diagram, step two you're writing your givens. The next step is we're going to write out our sum of forces. So sum of forces equals MA. So our sum of forces is where we plug in our unbalanced forces. And so we can say since this isn't moving up or down or vertically, we know that our normal force and force of weight have to be balanced. However, since we are moving to the right, we know that our forces going to the left and the right are unbalanced. So we need to apply what direction they're moving in. So the direction of motion is what we consider to be the positive direction. So for instance, this object's moving to the right. So we're going to label our applied force just with a positive symbol and our frictional force with a negative symbol. So anything that points in the direction of motion is positive. Anything that points in the opposite direction is negative. So then to substitute in this weird squiggly sigma, which means sum of forces, we just write our positive force minus our negative force, and we just set it equal to MA. So all I'm doing is taking my unbalanced forces off of my free body diagram after I assign direction, and I'm just plugging them in for the sum of forces, or that sigma F. And then from here, we can solve for acceleration. So all we have to do is get this A by itself. So we're just going to divide by M on both sides. And we're getting an equation that looks like FA minus FF divided by M equals acceleration. And so now before we start plugging in numbers, we need to make sure that we have everything we need. We can see we have an applied force, we have a mass, but we don't have our frictional force. So that's something that we're going to need to solve for. So I'm just going to come over here to the side and say we know that our frictional force is equal to the mu times the normal force. So we have our mu, but again, we don't know our normal force. But let's think about that. If we know our force of weight and normal force are balanced, which means they have to have the same magnitude or number, how could we solve for normal force? If we know that force of weight equation is just mg, couldn't we also say that to find our normal force, we're also just going to do m times g? Because they're the same thing. So for my friction equation, I'm just going to substitute in for normal force, mass times gravity. So we have our mu, we have our mass, and we're going to say gravity is that magic 9.8 or 10. And so I'm just going to go ahead and plug in my 0.75 times my 28.6 times 10. And that's going to give us our frictional force. So we're just multiplying all three of those together. So we should end up with a number around 214.5 newtons. Right? And so now that we know that, we can go back and we can just plug in our values. We say our applied force from our list of givens is 302. Our frictional force that we solved for is 214.5 divided by our mass of 28.6. So all we got to do is put all of that in our calculator, and we should get something around 3.2 meters per second squared. And so that's going to be how we get our acceleration. All right, so I want to take a look at one more. So remember, number 2 is what we're going to look at. And remember, step 1 is draw the free body diagram. Step 2 is write out your givens. And step 3 would be the sum of forces. So after you read number 2, I'm not going to read it for the sake of time. We're going to draw out our free body diagram. We're going to have force of weight or gravity going down, normal force going up, applied force to the right, and frictional force to the left. So that's step 1. Step 2, we're going to write out our givens, or everything that the problem gives us. So we should see that it gives us mass, because it says in the problem 300 kilograms. And we know kilograms is something that we measure mass in. It also gives us that mu, or that weird number. So anytime you see a number less than 1 and without units, that's more than likely going to be your mu. And then it also gives us our acceleration. And we're looking for our applied force. So step 1, draw the free body diagram. Step 2, write out your givens. And then step 3 is when we start looking for the sum of forces. So now what we're going to do is we're going to plug in all our unbalanced forces for our sigma F. So we are going to look at our free body diagram and decide what's balanced and what's unbalanced. So if we look at the forces going vertically, normal force, force of weight, we know that those are going to be balanced because we're not moving in that direction. However, our horizontal forces are going to be unbalanced. Again, we have a type of acceleration, so we know we have some type of unbalanced force. But now we just need to assign them direction. Remember, positive is always in the direction that the object's moving, and negative is going to be everything pointing in the direction that it's not moving. So again, we're just going to write this out as FA minus FF equals MA. But now we're looking for applied force, so we just have to get this FA by itself. So we're going to add force of friction to both sides, and we're going to end up with FA equals mass times acceleration plus force of friction. We don't know our value for frictional force, but we do know an equation to find it. So we could just rewrite this by saying MA plus mu times the normal force. But again, remember, we don't know normal force, but we know that since they're balanced, if I find force of weight, I can also find normal force. So I'm just going to go and plug in my M times G there. So I'm going to end up with 300 times 0.58 plus my mu of 0.8 times my 300 times 10. So we're just multiplying MA together and then multiplying all three values here. And so for our applied force, we should get 2,579 newtons. Oh, excuse me, that's supposed to be 74. 74 newtons. All right, so that's 1 and 2. So I want you guys, if you haven't finished these yet, I want you guys to go through the rest of them, so 3 through 9. And if all you can do is draw the free body diagrams and the givens, that's step 1 and 2. Then step 3 is when it gets a little more tricky because you have to start identifying your unbalanced forces, assigning direction, and you also have to remember all 3 of these equations up here and know what's a good time to plug them in. So I hope 1 and 2 helped you, but we're also we can have another Zoom to discuss 3 through 9. So email me if you guys have any questions.